food orders. We will be having trivia, and that is, we do have sheets up front here. If you did not get a sheet, please pick one up at the front. We do have a limit of 5 people per team. We do have prizes to give out. We would also ask you to think of a very creative astronomy-related name. I don't think, we're all nerds here. We all came downstairs into the basement on a bright sunny day to listen to astronomy, so you're not going to be, you're in good company here. And also on the back, we do have a little survey to see, we want to know how you found out about us. So if you could just check a box there to let us know how you ended up finding out about State College, that would really help us out a lot. So I think without any further ado, we'll get to our first talk today. We have 3 talks. We have 2 talks on the TRAPPIST systems by Dr. Thomas Beatty and Becky Dawson. And then we also have 1 talk on hidden figures and other hidden figures in astronomy by graduate student Jacob Lund. So our first talk is by, sorry? Jonathan, I was going to, sorry. Jonathan Jackson is going to talk about hidden figures. They like to stay and to live together, whatever. So our first speaker is going to be Thomas Beatty. He's going to tell us about TRAPPIST-1. He is a Pisces. He likes long walks on the beach, short walks on the beach, anything beach related. I would like to point out that he asked me to say that. So go ahead and Thomas, take it over.
That's false, by the way. I did not tell him to say that. How are you guys doing? We're in the basement listening to astronomy talks. I'm supposed to stand over here under the light this way. Can you guys hear me okay? Okay. Right, so what I'm going to talk to you about is this system that's called TRAPPIST-1, which you guys may have heard about in the news. It was sort of all over the place a couple of months ago. The reason why is because it's a whole series of planets that are around another star that they found a couple months ago. And the exciting thing is that it's in the habitable zone around that star, right? So it's at the right distance from the star that liquid water could exist on the surface of the planets. It's actually particularly relevant here because Trappist monks make a lot of beer in Belgium.
Yeah, they do.
Right? So it's good for an astronomy on tap. That's why, I gotta be honest, I feel like I'm sort of been on like a Pilsner kick the last couple of weeks. But I don't think they have Pilsners here. So I got a Belgian white in honor of Trappist. And here's one of the monks looking in. He's not looking at the planet, he's looking at the actual beer. But anyway, so there's all these planets. They're in what's called the habitable zone, so potentially they could support life. This was in a lot of newspapers. I couldn't find it. I was trying to find a good headline for this, like the New York Times or something. But a lot of them said, our best bet to find alien life elsewhere in the universe. But really, if you guys are science fiction fans, it's also, they're very close together. You can see from this poster. They're actually close enough that you could see them like we see the moon. You can see the other planets. That's how close they are. So really what we found is actually the universe from Firefly. There's one way to think about it. I found this on Reddit, and somebody spent a lot of time working out where things are in Firefly. I guess that sort of makes sense with the fan base. Anyway, so we have all these planets, and in all the press releases and all the images you see, you get these nice looking pictures of the planets. This one sort of looks like Earth. That one's green for some reason. That one's not so nice. But the important thing is that all these are illustrations, right? Is we don't actually know what any of these planets look like. What we actually have, what the actual data for this system looks like, is it looks like this. It's a black and white, very pixelated image. This is the star, so this is all we get. We get this, and we probably have about 3,000 images that are like that. I don't think it's going to play through all of them. We'd be here forever. Right? So how do we go from this to actually finding one of these planets that NASA can then make these nice illustrations and confuse everybody? Well, what we do is TRAPPIST is the planets are just the right angle that they pass in front of the star from our perspective on Earth. And so when they go in front of the star gets a little bit dimmer. And if you're looking at the star here in the image and you just figure out how much light is coming from the star, you add up each of those pixels, and then you make a graph of that light as a function of time. you end up that you can actually see all the planets. There's 7 different planets. You can see each of those planets going in front of the stars. So this is what we actually see and how we know that the planets are there. So the question is, okay, so we want to know if there's life on them. This is what we have, right? And what we want to know is how do we go from this to, is it like a beach paradise that you actually want to go to? Or is it something like Venus where, so the Soviets landed a lander on Venus in the 80s, and it melted about half an hour later because Venus's atmosphere melts metal. So the question is it going to be nice or is it going to be like Venus? And right now we have no idea what actually is going on. But I'm going to talk about how we can figure that out. So the easiest way is we just get Spock or the Enterprise to scan it for life, use the tricorders. I feel like they were always pretty unclear on what the range was on those things, so that might actually work. The actual easiest way is, you can imagine, is you can take a picture, right? Is you just get a picture, and maybe you don't get a nice picture, maybe you get a pixelated picture, but terrific, we're off to the races. The only problem with that is that the classic analogy that everybody uses is that trying to get a picture of a planet around another star is like trying to see a firefly that is, you're in New York and the firefly is in LA, and the firefly is about 5 feet away from the searchlight. And actually, so I was actually looking this up for this talk. It turns out that analogy isn't quite right, because the firefly is actually, like the firefly, the searchlight light ratio is actually a lot easier to pick out than the Earth and the Sun. This is actually about 1,000 times easier than seeing one of these planets directly. So the analogy doesn't quite work. So what do we do instead? So I said that the planets go in front of the star. They also go behind the star, so we can actually look. You can look as the planet goes behind the star, and you can look as the planet goes in front of the star. And you can try and use that to help you figure out what's going on. And so what happens is when it goes in front of the star, you can look at light that just goes through the top parts of the atmosphere. Right? If there's clouds, the light will be absorbed and you won't see anything. If there's no clouds, it'll come through and it'll look dimmer. And then if there's atmosphere, part of that light will be absorbed, and we can find out what's in the atmosphere by watching the light pass through the atmosphere as the planet goes in front of the star. So we've actually done this for a whole series of planets. This is one of them that's slightly bigger than the Earth, and you see it's sort of a flat line. So that means that they're clouds. Often when we do this, what we find is we just find clouds. We get a flat line, which is not very exciting, but if you do this with more precision, hopefully you could actually figure something out. Okay, so what do we actually look for when we're trying to find life on one of these planets? Well, you want to find out what's in the atmosphere, right? You want to look for something in the atmosphere that's going to tell you when you see it that there's life there. And there's a couple of examples here. There's methane, cows, a lot of organisms on Earth put out a lot of methane. Actually, cows are one of the major greenhouse gas contributors. Liquid water, oxygen. So in the solar system, Mars, Earth, and Venus are all sort of the same size, Venus and Earth in particular, but they all look very different. So this is a plot of the spectra coming off of Mars, Earth, and Venus with the color. And they have very different colors. So if you could measure that color, you could tell something about what the atmosphere is made out of. And we want to measure it in a way that you can get some sort of reactive gas. You know, something like oxygen. Oxygen is going to come out of the atmosphere very quickly. That's why we get rust. It rusts into things. And if we weren't here breathing it out, all the oxygen in the atmosphere would disappear on Earth pretty rapidly. So we want to find something like that. Another thing we can do is you can look for something called the red edge. So it turns out that plants are very reflective in the red. It's the way they prevent themselves from overheating. So if you take a picture of Earth, this is just normal, you know, what we normally see. This is slightly in the near infrared. Earth looks startlingly red in the near infrared, all the land masses, because it's all the plants that are reflecting all this red sunlight back up at us. Another thing you could do is that water and land actually reflect differently. They have different reflection properties, so you could try and work out what the water and land fraction of the planet is to see if it has continents. It looks like Earth. And this group did it with Earth. They tried to figure it out. You can't get it exactly, right? You can't get north and south, but you can get east and west. And so you know that there's a big landmass where Africa and Europe are. You get the Americas. You get the fact that the Americas are separated from Europe and Africa. But actually, the one problem it turns out with Earth is that is the moon. If you didn't know the moon was there, you just see the signal from the moon. So you'd think that Earth had one gigantic continent on one side of it, and it had a day that was about 28 days long, right? That's how long it takes the moon to go around. So if you didn't know the moon was there, you just think that Earth looks some bonkers thing, and you'd see the moon instead of the land. Okay, so we could also actually look for technology as well, right? We can look for life. We could actually try to look for technology directly. I like to say there's very few ways to win in astronomy, but I'm pretty sure if you found extraterrestrial intelligence somewhere, you would win at astronomy. Okay, so the first thing you can do is you can just look for radio waves. You can look for like lasers or something. Maybe they're beaming something at us, right? This is sort of the classic SETI, what you think of with the big radio dishes. If any of you guys saw Contact, anybody here? I feel like I often worry that my references are slowly getting more and more outdated. Right, so if you saw Contact, that was like radio dish SETI. They're looking for radio transmissions from the aliens. The problem is that it can often be hard to tell what you want to look for, or even if you found it. So this was something, you can't really see it. It says WOW right there. There was this signal in the 70s that somebody on a radio telescope saw that looked exactly like what you think an alien radio transmission should look like, but they only saw it once, and they never saw it again. And nobody's been able to figure out what the hell this thing is. So it's known as the WOW signal. Right, so we get stuff like this, and maybe it's aliens, maybe it's not, we're not quite sure. So we've been talking about the atmospheres. You could look for industrial pollution in the atmospheres, right? Maybe they're pumping out smog, maybe there's factories, and we could actually identify that. The problem is that a lot of smog actually doesn't get very high up. That's sort of the whole problem, is it stays pretty low down. So you want something that gets high up in the atmosphere. What that probably means is something like nitrous oxide, methane, CFCs. The only problem is nitrous oxide and methane, there could be natural sources of that. So if we saw that, that wouldn't be really a smoking gun. CFCs would actually be a really nice smoking gun. They don't last very long, so they'd have to be pretty recent. There's no natural sources that we know of. The only problem is that they're in a very complicated portion of the spectrum. So to really see it, right? So to actually see industrial pollutants in the atmosphere, they have to be very intense. There have to be a lot of them. Which pretty much means that the planet would be like the after effects of WALL-E. If we could see the industrial pollutants, we would probably not want to be there. There was probably some massive industrial accident that probably killed everybody on that planet.
Spoilers.
Oh yeah, has anybody here not seen WALL-E? Yeah, I feel like there's a statute of limitations on spoilers. Well, okay, FYI, WALL-E, Future Earth, but it works out. Right. So the way we do this, though, so there's a bunch of groups that are going to be trying to look at this in the next couple of months. The best way, the most precise way we're going to have is something called the James Webb Space Telescope, which is going up. I think it's a year and a half.
2018.
What are we at?
October. Yeah.
They kept moving the date.
No, October.
But this is
What year though? Yeah.
Yeah.
October some year.
So this is going to be the Hubble replacement. It's a lot bigger than Hubble. They've actually started building it. That's the mirror down at NASA Goddard in Maryland. It's going to be substantially bigger. This is what Hubble looks like. That's how big Hubble is. That's how big JWST is. So JWST will actually be able to measure a lot of these things. Hubble's going to be able to measure a lot of these things as well. So there's a bunch of groups that have just put in proposals to look at these systems to try and find life and stuff with the Hubble Space Telescope. Actually, proposals were due last Friday, like 3 days ago, which was super intense for anybody who's applying. So Hubble's going to look at it in the next couple of months, and JWST, when it launches, is also going to look at it and really nail this thing to the wall and try and figure out if there's actually life there, right? So, just to go back to Contact, I'm really glad you guys can see this. That, usually when we think about looking for alien life, we think about Jodie Foster with her headphones on, listening to the radio signals. But actually, in the next couple of months, in the next couple of years, the easiest way is not going to be through radio. It's probably going to be through a telescope and trying to look at this directly. So stay tuned. Hopefully you guys will see something in the news soon. Thanks.
We do have time for questions if anybody wants to ask Thomas and Jason.
Yes, Jason?
What about lithopanspermia? Trappist one.
So Jason's question is, what about lithopanspermia? Which means, what about the idea? Okay, so there's an idea, to quote Battlestar Galactica, that life here began out there. And so it's the idea that there are, like life on Earth, if you get an asteroid that hits the Earth, some of the rocks get thrown into space. Those asteroids can drift around and they land on Mars, or Martian asteroids come and land on Earth. And so you can move life from Earth to Mars by these asteroids. So Jason's question is, since these planets are so close together, I said that you could actually see them, like we see the full moon. Could you get impacts that then transmit the life by rocks to other planets in the system? So you may know the answer to this question better than I do, Jason. But, yeah, it works really well. Yeah, I presume it would work really well. Yeah, I mean, it should be possible. The problem is it's just super low odds in the solar system, but the odds should be way higher in TRAPPIST because everything's so close together.
I thought JWST was looking at totally different wavelengths than Hubble. Like it's not really a Hubble replacement. That's correct.
So the question was, isn't JWST looking at different wavelengths than Hubble, so is it really a Hubble replacement? Yes, that is completely correct. I was being a little imprecise there. I do a lot of my work in the near infrared, so for me it's a Hubble replacement. But yes, you're correct. For stuff like in the optical or the UV, JWST is not going to be able to look at. But a lot of at least thinking about exoplanet atmospheres, a lot of the molecules that we want to see are often easiest to see in the near IR. So for atmosphere stuff, it's going to be very exciting.
One more question.
So how do you get that detailed of information from an image that's like 6 pixels by 6 pixels?
Okay, so the question was, how do you get that detailed information from a 6 by 6 pixel image? So that's sort of the whole game, right? That's like what people spend years of their lives trying to figure out. So the difference is, so what I showed you was just one image, right? And we were flipping through it in time. So that just gives you the brightness. You could also imagine that you could separate it up into different colors, right? You could take an image of one color, an image of another color. And usually when we think about colors, it's like red, green, and blue, right? But you could make like a whole bunch of different colors. You get a whole spectrum out of it. You get wavelength information, right? So that's the way mostly that we get all the information out. So we look at the very fine-grained, how the color of the light varies, and how that varies as a function of time, and that tells you a lot. I mean, the way we know what something is, right? Like when I look at this beer, the way I know that it's beer is because it looks sort of orange and cloudy, right? So what that actually is, though, is that's the light that's coming off the beer has certain contours to it. And our brains, we can recognize those contours in our head, right? What we're doing is we're measuring it using telescopes, and we're looking for those same contours, and then backing out what things have to be from that.
Had a good time. I agree.
Do we get to participate in the trivia?
You can participate in trivia.
Alright, so we are going to be starting trivia right now. If anybody does not have a sheet, you can grab one up front here. I hope you have time to think of a clever astronomy team name. So